Hello my friends, and welcome back to KrossUSA channel. Today, we're taking you on an incredible journey, from the towering forests of Oregon to the traditional sawmills of Germany and the cutting-edge facilities of Sweden. We'll witness the complete transformation of mighty trees into the lumber that builds our world. Whether you're a craftsman, a construction professional, or simply fascinated by industrial processes, this comprehensive look at modern forestry and sawmill operations will give you a whole new appreciation for every piece of wood you work with. So grab your coffee, settle in, and let's dive into this fascinating world of timber processing. Our journey begins in the pristine forests of Oregon, where the magic starts with some of the most impressive machinery you'll ever see in action. We're witnessing the Tigercat 720E feller buncher at work. And folks, this machine is an absolute beast. NTHE Tigercat 720E is powered by a massive Caterpillar C9 engine producing 275 horsepower. But what makes this machine truly remarkable is its precision. Watch as the operator, sitting comfortably in a climate-controlled cab with 360-degree visibility, maneuvers this 40-ton giant through the forest with the finesse of a surgeon. The felling head, that's the business end of the machine, can handle trees up to 24 inches in diameter. Here's what's fascinating. The accumulator head can actually hold multiple trees at once before laying them down in neat piles. This isn't just brute force. It's intelligent harvesting. The head rotates 360 degrees and tilts up to 45 degrees, allowing the operator to position trees exactly where they need to go. Notice how the rubber tracks distribute the machine's weight, minimizing soil compaction and environmental impact. Now watch this incredible process unfold. Once the trees are felled, they're systematically bucked. That means cut to specific lengths based on quality zones within each log. The operators are reading the wood like a book, identifying defects, determining optimal lengths, and maximizing the value of every single tree. Here comes our second star, the Tigercat 240B forwarder. This machine is the workhorse of the logging operation, and its engineering is simply brilliant. The 240B features an articulated design that allows it to bend in the middle, giving it incredible maneuverability in tight forest conditions. With its 8-wheel drive system and individual wheel suspension, it can navigate terrain that would stop most vehicles dead in their tracks. NTHE loading system is where the real magic happens. That massive hydraulic crane can reach out 32 feet and lift up to 200 pounds at full extension. Watch how the operator delicately picks up these massive logs, some weighing several tons, and arranges them in the bunks with the precision of playing with Lincoln logs. The computer-controlled stability system automatically adjusts the machine's balance as it loads, preventing tipovers even on steep terrain. These aren't your everyday semi-trucks. We're looking at trucks equipped with specialized bunks, reach extenders, and self-loading capabilities that can handle loads exceeding 80,000 pounds. NTHE loading process is orchestrated chaos at its finest. Hydraulic log loaders, often mounted on the trucks themselves, position each log for optimal weight distribution and securing. Every chain, every binder, every positioning decision is crucial for safe transport over what could be hundreds of miles of highway. And now we arrive at our destination, Dr. Johnson Lumber Company in Riddle, Oregon. A second-generation, family-owned operation that's been producing quality Douglas fir lumber for over 69 years since Don R. Johnson founded the company in 1951. As our truck enters the mill yard, we're witnessing over 7 decades of lumber industry evolution. What started as a small operation with just 10 employees has grown into a sophisticated facility that exemplifies American lumber craftsmanship. NTHE logs first enter the log yard, where they're sorted by species, size, and quality grade. This isn't random. It's a carefully orchestrated system. Douglas fir, Oregon's premier construction timber, requires specific handling protocols. Each log is scaled and graded, with measurements recorded for inventory and production planning. NTHE log handling equipment here includes massive forklifts capable of moving 20-foot logs weighing several tons, and overhead cranes that can position logs with surgical precision. The yard is designed for efficient flow. Logs move from storage to the mill in a logical sequence that minimizes handling and maximizes processing speed. Now we enter the heart of the operation, the head rig. This is where massive logs become lumber, and the process is absolutely mesmerizing. The head rig at Dr. Johnson is a computer-controlled scanning and sawing system that reads each log like a fingerprint. Here's how it works. As each log approaches the head rig, laser scanners and cameras create a three-dimensional map of the log, identifying defects, measuring taper, and calculating the optimal cutting pattern to maximize lumber yield. The computer brain running this operation processes thousands of calculations in seconds, determining exactly where each cut should be made to produce the highest value mix of lumber grades. The carriage system holds the log securely, while massive circular saws, some with teeth that cost $50 each, slice through the wood at incredible speeds. These aren't ordinary saw blades. They're precision-engineered cutting tools that maintain their sharp edge while processing hundreds of logs per day. The main saw typically runs at about 900 RPM, but with a blade diameter of 60 inches or more, the rim speed exceeds 150 miles per hour. After the head rig makes the primary cuts, the resulting cants and slabs move to the gang saw or resaw operations. This is where the rough lumber takes its final shape. Gang saws use multiple parallel blades to slice cants into dimensional lumber in a single pass. Imagine a giant version of slicing bread, but with wood and incredibly sharp steel blades. NTHE edging process removes the natural edge of the board, creating straight, parallel sides. Computer-controlled edgers use optimization software to determine the best width to cut each board, maximizing recovery while meeting lumber grade standards. It's fascinating to watch these machines make dozens of decisions per second, each one affecting the final value of the lumber. What makes Dr. Johnson's operation particularly impressive is their integration of modern technology. The facility includes advanced equipment like USNR systems and Hans Hundiger AGCNC machinery, representing the cutting edge of lumber processing technology. NTHE scanning systems don't just measure, they predict. By analyzing grain patterns, growth characteristics, and defect distributions, these systems can forecast lumber grades before the cuts are made. This predictive capability allows the mill to optimize not just individual cuts, but entire production runs. Every piece of lumber produced at Dr. Johnson undergoes rigorous quality control. Trained graders inspect each board, looking for characteristics that determine its structural properties and appearance grade. Douglas fir lumber grades include structural grades like Select Structural, number 1 and number 2, each with specific strength properties and allowable characteristics. NTHE grading process combines human expertise with machine assistance. Automated grading systems use cameras and sensors to identify defects and measure characteristics, but experienced graders provide the final quality assessment. Their trained eyes can spot subtleties that machines might miss, ensuring that every board meets the exacting standards that have made Dr. Johnson lumber trusted by builders for nearly 3/4 of a century. NNTHE finishing processes include planing, where rough lumber is smoothed to precise dimensions, and kiln drying, where moisture content is reduced to specified levels. The kiln drying process is crucial. It reduces warping, checking, and shrinkage while improving the lumber's strength properties and workability. Modern kilns are computer-controlled environments where temperature, humidity, and air circulation are precisely managed throughout the drying cycle. For Douglas fir construction lumber, the process typically takes 3 to 7 days, depending on thickness and desired moisture content. And as we watch the finished lumber being packaged and loaded for shipment, we're seeing the culmination of a process that began in the forest and transformed raw timber into the building blocks of America's construction industry. The story of Dr. Johnson lumber ultimately reflects the broader narrative of American manufacturing resilience, innovation, and adaptation. From a small sawmill founded in 1951 to a technology-forward producer of advanced building materials, their journey demonstrates how family businesses can compete and thrive in global markets while maintaining their core values and community commitments. NNTHE Douglas fir processed at Dr. Johnson isn't just any wood. It's among the world's premium structural lumber species. Oregon's unique climate conditions create Douglas fir with exceptional characteristics that have made Pacific Northwest lumber the global gold standard for construction applications. NTHE technical specifications tell the story. Oregon Douglas fir typically achieves specific gravity ratings of 0.48 to 0.55 when kiln dried, significantly higher than most softwood species. This translates to superior strength properties, with bending strength values reaching 12, 500 to 13, 100 pounds per square inch. The modulus of elasticity, essentially the wood's stiffness, ranges from 1.8 to to 1.9 million psi, making it ideal for structural applications where deflection control is critical. These properties result from Oregon's maritime climate, where moderate temperatures and consistent moisture create slow, even growth patterns. Trees harvested for Dr. Johnson's operations typically range from 80 to 120 years old, compared to 25 to 40 years for fast-growing southern pine. This extended growth period creates the tight-grained structure and high density that builders prize. Family lumber operations like Dr. Johnson represent more than just manufacturing facilities. They're economic anchors for rural communities. The multiplier effects of lumber production create jobs throughout the supply chain, from logging contractors to equipment suppliers to transportation companies. Towns like Riddle, the concentration of timber-related businesses creates what economists call agglomeration benefits, efficiencies that arise when related industries locate near each other. Skilled workers can move between companies. Suppliers can serve multiple customers efficiently, and specialized services develop to support the cluster. This community integration also provides stability. While global corporations might relocate operations based on short-term economic advantages, family businesses like Dr. Johnson are rooted in their communities and committed to long-term local success. Now let's travel across the Atlantic to the heart of Germany's Black Forest region, where we discover a completely different approach to lumber processing. The Dewald Sawmill in Böhringen represents centuries of German engineering tradition, where time-honored techniques meet practical efficiency in ways that will absolutely fascinate you. Böhringen sits in the Baden-Württemberg region, an area renowned for its dense forests and centuries-old timber traditions. Here, sawmilling isn't just an industry, it's a cultural heritage passed down through generations. The Dewald operation embodies this tradition while serving the practical needs of local builders, furniture makers, and craftsmen who demand the highest quality hardwoods and softwoods. German sawmills like Dewald have evolved differently from their American counterparts. Where American mills focus on high-volume production of standardized lumber, German mills emphasize precision, quality, and the ability to process diverse species for specialized applications. This philosophy is evident in every aspect of the Dewald operation. At the center of the Dewald mill stands their pride and joy, a traditional German saw frame, or Sagegatter as it's known locally. This magnificent machine represents nearly 150 years of German engineering refinement, and watching it work is like witnessing industrial choreography. NTHE saw frame operates on a fundamentally different principle from American circular saws. Instead of spinning blades, it uses multiple parallel gang saw blades mounted in a heavy reciprocating frame that moves up and down in a precise vertical motion. The log is slowly fed forward on a carriage while the blades slice through the wood with each downward stroke. What makes this approach so special? First, the blade configuration allows for incredibly precise spacing between cuts. German sawyers can achieve tolerances that would make a machinist proud. We're talking variations of less than a millimeter across a 12-foot board. This precision is crucial for the high-end joinery and furniture work that German craftsmen are famous for worldwide. NTHE blades themselves are works of art. Each saw blade is hand-tensioned by a skilled filer who understands exactly how much stress each blade can handle. The teeth are shaped and sharpened to specific profiles depending on the wood species being processed. Hardwoods require different tooth geometry than softwoods, and the German tradition recognizes these subtleties. NNLOG preparation at Dewald begins long before the wood reaches the mill. The operators work closely with local foresters to select trees at optimal harvest timing. German forestry practices emphasize sustainable harvesting and species diversity, so the mill regularly processes everything from local spruce and pine to premium hardwoods like beech, oak, and ash. Each log is individually assessed for its best use. This isn't mass production, it's artisanal manufacturing applied to industrial processes. Logs destined for furniture-grade lumber receive different treatment than those intended for construction use. The experienced mill operators can look at a log and envision the final products it will yield. One of the most impressive aspects of traditional German sawmilling is the manual cant turning process. After the initial cuts are made, the cant, that's the squared-off center section of the log, must be repositioned for additional cuts. In modern mills, this is done automatically, but at Dewald, skilled operators manually position each cant. This might sound inefficient, but watch the expertise at work. These operators understand wood grain in ways that computers are just beginning to match. They can spot internal defects, predict how the wood will behave as it's cut, and position the cant to maximize both yield and quality. It's knowledge that comes from decades of experience and represents a skill set that's becoming increasingly rare in our automated world. And German mills like Dewald are masters of species-specific processing. Each wood species requires different handling, and the traditional approach recognizes these differences in ways that mass production often misses. NFOR hardwoods, like European beech, the sawing pattern emphasizes grain orientation for stability. Beech is notorious for movement during drying, so the cutting pattern must account for internal stresses and grain direction. The experienced sawyers at Dewald cut beech with specific angles and sequences that minimize waste from warping and checking. Oak processing follows completely different protocols. German oak is prized for its tight grain and durability, qualities that must be preserved through careful sawing. The traditional approach uses slower feed rates and specific blade tensions that minimize grain tear-out and preserve the wood's natural beauty. NNTHE drying process at Dewald combines traditional air drying with modern kiln techniques in ways that optimize both efficiency and quality. The lumber yards are laid out to take advantage of natural air circulation patterns with careful attention to prevailing winds and seasonal weather changes. Nair drying stacks are built using traditional German stacking methods, where the stickers, those are the small pieces that separate the layers, are placed according to species-specific requirements. Hardwoods require different sticker spacing than softwoods, and the stack heights are calculated to provide proper weight compression while allowing adequate air circulation. German lumber grading standards are among the most stringent in the world, and mills like Dewald have built their reputations on consistently meeting these exacting requirements. The grading process combines visual inspection with precise measurements, ensuring that each board meets not only strength requirements, but also appearance standards. German graders are trained to identify characteristics that might be acceptable in other markets, but are rejected for premium German applications. The attention to detail is remarkable. They're looking at factors like grain orientation, growth ring consistency, and surface characteristics that many other grading systems would overlook. What really sets Dewald apart is their ability to produce specialized products that modern automated mills simply can't match. They regularly process timber for restoration projects of historic buildings, where the lumber must match specific dimensional and quality standards from centuries past. Custom sawing requests might include everything from specific grain orientations for musical instrument makers to precisely dimensioned timber for traditional German timber frame construction. This flexibility requires not only traditional equipment, but also the knowledge and skill to use it effectively. Perhaps most importantly, the Dewald operation demonstrates the irreplaceable value of human expertise in wood processing. While modern mills rely heavily on automation and computer control, traditional mills like Dewald prove that experienced operators can make decisions and achieve results that technology alone cannot match. NTHE mill operators don't just run machines. They read wood, understand its behavior, and make countless small adjustments throughout the day that optimize both quality and yield. This human element is what transforms wood processing from mere manufacturing into craftsmanship. Our final stop takes us to the forests of northern Sweden, where we encounter Dorotea Såg, a mill that represents the pinnacle of Scandinavian lumber processing technology and environmental stewardship. Here, cutting-edge automation meets centuries of Nordic forest wisdom to create what many consider the most efficient and environmentally responsible sawmill operations in the world. NNTHE forests surrounding Dorotea Såg grow some of the world's finest construction timber. The slow growth rates in Sweden's northern climate create incredibly dense, strong wood with tight, even grain patterns. These trees might take 80 to 120 years to reach harvest size, but the result is lumber with strength characteristics that exceed wood from faster-growing regions. NNTHE Dorotea Såg processing system begins with one of the most sophisticated log sorting operations you'll ever see. As logs arrive at the mill, they pass through a scanning station that creates detailed 3D models of each individual log. This isn't just measuring diameter and length. The system is analyzing internal defects, grain patterns, density variations, and growth characteristics. NTHE scanning technology uses a combination of X-ray, laser measurement, and computer tomography to see inside the log before it's ever cut. This predictive analysis allows the mill to make cutting decisions that maximize both lumber yield and quality grades. This system can identify internal knots, rot, and other defects with accuracy that would be impossible for human graders. NTHE, heart of the Dorotea Såg operation, is their fully automated sawing line, a marvel of Swedish engineering that processes logs with speed and precision that has to be seen to be believed. The entire line is controlled by sophisticated software that makes thousands of optimization decisions per minute. Each log is positioned by robotic systems with tolerances measured in millimeters. The primary breakdown uses high-speed circular saws with automatic blade positioning that can adjust cutting patterns in real time based on the scanning data. The blades themselves are technological marvels. Carbide-tipped cutting tools that maintain their edge through hundreds of logs while operating at rim speeds exceeding 200 miles per hour. What sets Swedish mills apart is their integration of quality control directly into the production process. As lumber emerges from the primary breakdown, it immediately passes through additional scanning stations that verify dimensions, identify defects, and assign preliminary grades. This real-time feedback allows the system to make adjustments on subsequent logs. If the scanning system detects that a particular cutting pattern isn't yielding expected results, it can modify the approach for similar logs. This adaptive optimization is what allows Swedish mills to achieve recovery rates that exceed 80%, meaning more than 80% of the log volume becomes saleable lumber products. NNTHE environmental integration at Dorotea Såg is extraordinary. The mill operates on a zero-waste principle where every piece of wood finds a use. Sawdust becomes compressed wood pellets for heating fuel. Wood chips go to paper mills. Even the bark is processed into landscaping products. NTHE Mill's energy needs are met entirely by burning waste wood products in highly efficient boilers that not only power the mill, but also provide district heating for the local community. The emissions control systems exceed European environmental standards, and the entire operation actually has a negative carbon footprint when you account for the carbon stored in the lumber products they produce. NNTHE lumber drying process at Dorotea Såg represents the state-of-the-art in controlled drying technology. Their kiln systems use radio frequency heating combined with conventional hot air drying to achieve precise moisture control throughout each board. NTHE radio frequency technology penetrates deep into the wood, heating it from the inside out while the conventional kilns control surface conditions. This dual approach reduces drying time while minimizing the stress that can cause warping, checking, and other defects. The result is lumber with exceptional stability and consistent moisture content throughout. NNTHE final stages of processing are handled by fully automated systems that would look at home in a modern electronics factory. High-speed cameras and sensors inspect every surface of every board, measuring dimensions to thousandths of an inch and identifying grade-determining characteristics. NTHE grading decisions are made by artificial intelligence systems trained on millions of lumber samples. These AI systems can identify subtle characteristics that even experienced human graders might miss, ensuring consistent grade standards across millions of board feet of production. And Swedish mills like Dorotea Såg prove that high-volume production and environmental responsibility aren't contradictory goals. Through intelligent use of technology, deep understanding of wood science, and commitment to sustainable practices, They're setting the standard for 21st century lumber processing.